All right, now that we understand how to state relationships, let's, or even what stating a relationship is, let's look at some real examples of relationships in science. So what is the relationship between percent sugar solution and average final height of a plant? So what they're saying is, like, if they keep on giving more and more sugar and water to a plant, what happens to its height? So what we see is that as the percent solution increases from 0, 10, 20, 30, so as the sugar increases, the height of the plant is then going to, in this case, decrease. So main point, as one thing increases, we're going to follow this other side in the same direction, and it's going to decrease. Now we can do that the opposite way and start by looking at the average final height. So as the average final height increases, what happens to the percent of sugar solution being added? It is being decreased. So that is an indirect relationship, which indirect means as one thing increases, the other set of information then decreases. Okay, so that's indirect. So average insolation reflected during the summer versus time or years. So as the years increase from 2006 to 2007, 2008, blah, 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 all the way to 2012, what happens to the average insolation reflected during the summer? Does this number go up or does it go down, right? So this number, the years, increases, while this number decreases. So again, this is an example of an indirect relationship. Now let's look at an actual bar graph. In earth science, we mostly do line graphs, but we can analyze this data for the bar graph. So this is going to be the average monthly Virginia beach sea temperature. So what we're looking at is what's the temperature at the beach in these different months: January, February, March, April, May, June, July, August, September, October, November, December. And what do we see? We see in the beginning a little decrease, and then an increase in temperature, and then a peak, right? And then we end up decreasing again. So one thing that really sticks out to me is that this is temperature throughout a year. And with seasons, it gets cold in the winter, hot in the summer. Cold in the winter, hot in the summer. So this is not just a direct area, but there's also some indirect, and it cycles back and forth between decreasing, increasing, decreasing, increasing, decreasing, increasing, and that is going to be cyclic. Now, if they just asked you, what is the relationship between temperature and time between March and July? Well, if we're looking at March just to July, the temperature increases, 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 right? And we're going to be saying that as time increases, the temperature increases. So for this data right between here, this is a direct relationship. But when we look at the entire thing, that is an indirect relationship. I'm sorry, that is a cyclic relationship. Cyclic, because it cycles between hot and cold. So let's take a look at the distance from the sun. So here are the planets, right? So as the distance from the sun increases, we go higher and higher numbers. What happens to the orbital velocity, or the speed of the planet? So as the distance increases, the orbital velocity appears to decrease. The numbers get smaller and smaller. So that is going to be what stating a relationship is for looking at data and graphs. So again, so we have the number of days for the percent of moon illuminated. So if we look between, I don't know, October 5th and November 30th, as the days increase, the percent of moon increases, then decreases to 0, then increases, then decreases, and we see a cycle again, okay? So that's our cyclical change, or a cycle. But if we're just asked to look between October 13th and October 29th, as the days increase, the percent of moon decreases, okay? All right. So now let's look at some rate of change questions. All right. So rate of change is just going to be a subtraction of two numbers divided by the amount of time that goes by. Okay. So the temperature outside changed from 10 degrees Celsius to 25 degrees Celsius between 8 a.m. and 11 a.m. How much did the temperature change every hour? So I'm going to direct you over here, and we're going to try that out. So what the question gave us was a rate of change question. A rate of change is just subtraction and then division, meaning that we have a change in value. In this case, it's temperature for that example, divided by the change or the amount of time that goes by. So in this case, the example reads, the temperature changed from 10 degrees Celsius to 25 degrees Celsius. So that is our change in value, 10 to 25 degrees Celsius. And I always like to put the smaller number second, because I like to do a big number minus small number. Okay, big number minus small number. And then the time was 8 a.m., small number on the right side, and 11 a.m. So let's start with just subtraction, and then we'll divide. Okay, so if we do 25 minus 10, this is going to be 15 degrees Celsius, and the amount of time between 11 and 8 a.m. is 3 hours. So that means over a 3-hour period, 8 a.m. to 11 a.m., the temperature changed 15 degrees, which was going from 10 degrees to 25 degrees. Now we have a fraction here, and we're not complete because we can't just leave a fraction. Fractions just mean division. So we plug the top number in the calculator first, divide it by the lower number, and we get 5 degrees Celsius per hour. And all that means is that in order for us to go from 10 degrees Celsius to 25 degrees Celsius over a 3-hour period, the temperature has to rise 5 degrees every hour in order to do that. Okay? So let me show you a little bit of a graphing representation of that, and then we'll be all set for you to complete the activity. So, the temperature, 25 to 10 degrees Celsius, was the change of 15. So we did the subtraction, and then we set up the bottom, right? We do subtraction again. The time changed from 8 a.m. to 11 a.m. So 11 minus 8 is 3, and that sets us up with that fraction that we just saw on the board. A fraction is division. So if we do 15 divided by 3, it gives us 5 degrees Celsius per hour, where we keep the C over the hours. Degrees Celsius over slash, right, hours. Okay. And this is going, we'll skip that. We'll skip that. Let's just focus on getting this next activity done, and then we'll get into this more complicated stuff next time.